So what we're going to be doing is these two exercises, which basically they're completing each other. And let me push this on the screen. I wish I could push this on your phones as well, but I can't. So I will recreate everything from scratch, but you see, if you'd like to go with this exercise, it explains this kind of explains a little bit what needs to be done, so you can follow that if I'm going too quick, or if you'd like to review as well. I'm going to go back to this later just to test these things, and also my objective is to finish these two exercises, this one and that one, which means this interface, the movable point and the movable circle, plus these are the same, and then the movable rectangle, so we can do all of them. And later on you can, as an exercise for yourself, if you just would like to test yourself, you can add a movable square that inherits from a rectangle, which is quite easy actually, not a big deal, except that some minor changes. So that's the idea. So let's get into that. So let's start with this interface first. This is what we're going to be doing. We did it previously, so I'm not going to be using that one. I'm just going to be starting from scratch. So let's call it week 3, exercise 1 and 2. So this is a new project, and you know what, I have so many of these projects now, it's becoming too much. I will just click on one of them and click on the rest. With the shift key pressed, I click on the others, it's going to select them all, and I'm not going to be doing anything except closing those projects, which means they're still there somewhere in where I stored them or saved them. It's just I'm not going to be able to see them here as a list, so it will be less crowded there and less confusing. I closed that one too, so I'm just keeping only this one, this new one. Now this is the one that has the main, the class that has the main. I'm going to create a new one, the interface actually, the movable. So the movable interface will be having only this void move up, and copy and paste, move down, right and left. I'm sorry? Movable E? Where would you want to put E? No, it's movable. Yeah. So move up, down, left, right, and we have that. Now I'll just like to create this movable point. So let's create that class, movable point. And this class is going to be implementing the interface, because you have this dash interface line. This means this is some kind of inheritance, right? But this dashed one means this class is implementing an interface and not extending a class. Yes, your question?
There is a plus sign and move up, down, left.
Plus means it's public.
You let it package.
Plus means public. The package is this tail thing. This is the package.
What did you put in the movable?
Yeah, because you were not here yesterday, so you missed the part when we said that even if you don't put public, it's going to be public by default. Yeah. And even if I did not put abstract, it's abstract by default. So you can just do this. It's not going to hurt you or change anything to the fact that, I mean, this one is public and abstract as well. If you want to type it, you can type it if you want to. But if you don't, that's implicit. So now let's have this movable point. This movable point has these package access. We have x, y, x speed and y speed. Do you understand what this x speed and y speed means? Because when you move something, you move it to a speed. If you remember yesterday, we moved it by 1. I can change that. Maybe I would like to move by 2 or by 5. So this is where I'm going to store what's the speed that I'm going to use to move something to it with it.
I think speed x, speed y would be
But I'm preparing to allow the users of this class to be able to specify, exactly as you mentioned, the speed of x and y. So they will enter that when, well, in the main or maybe in another class. It doesn't have to be always in the main, and you're going to see maybe I'm going to do something from another class, like from movable circle here, because movable circle, again, this symbol means that this movable circle is including this class movable point, which means if I see here, this is just to make you realize that this movable point here is this one. This is the class that I mean here. So this movable point is this one. So now this movable point, it implements, we don't for an interface, we don't inherit from an interface, we implement it. Because once you implement, you have to come up with the code of all the abstract methods in the interface. So I need to have all these defined. And one way to generate them all is to just click here and then implement all abstract methods. This is going to generate them all with some kind of exception that is going to be thrown. But I can just remove that and then put the code that I need, or the code that I would like you to use. So I'll leave it like this for now, because I just would like to continue with the rest. So now what is the rest? I would like to define those instance variables x, y, x speed and y speed, all of them ints. Notice that this tilde is the symbol, the representative of the package, which means I'm not going to be using any public or private or anything. I'm just going to say int x and just copy paste, and this is y and x speed and y speed. Now that I've done this, I need to have this one constructor that is going to be initializing all of them. So let's do that. Let's select all and generate. Now this is just going to take all this information, then store it into this these instance variables. Now the toString, well, let's just have a toString that is going to be basically the default one generated by the NetBeans, which gives me this is the x, the y, and this is the speed of the x and y, the speed of the y. Now what I need to do is to move this move up, move down, left and right. How do you move a point up and down and left and right? Actually, if you don't have to guess, there's a lot of assistance that is given to you here. So you can see, for example, now the y-axis pointing down for 2D graphics. This is something that I did not talk about it yesterday. Actually, I explained it differently when I said that you move up and down. But when you're on a graphics, because now we're getting ready to move to something that we're going to draw on the screen, I'd like to talk about the fact that in a screen the axes are not always the way we're used to them in math. Let's say in math you have this is x and y, and this is how you do that, right? This is 0 and then this is x, positive x, and this is positive y, right? This is how it works. But on a screen it doesn't work this way, because a screen is actually a screen. So if this is your screen, so they decided that the axis is not from here there. Why is that? I have no idea. You can Google that, but let me tell you exactly how they did it. They did it this way. This is the 0, this is the positive x, and this is the positive y. Is it bothering? Well, just you're not used to it, that's it. Now if I say this point over here, I would like to put it down, I want this point to be here, which means now I need to increment the y. That's all I need to do. If I was here and then I'm putting it down, I need to decrement the y. But because how it works on when you'd like to work with graphics on a computer, this is how it works. The axes are this way, so you have to now just adapt. That's why what they said here is that the y-axis is pointing down for 2D graphics, and this move up is actually because you're moving up, which means you need to reduce the y to move up. If you'd like to move up this one, if you'd like to move it up, which means you have to reduce to subtract from the y. It's because I want it to be here now, so I need to reduce the y. So that's how it is. I hope you're confused enough and you can manage it. Yes. By one? No. Well, if we didn't have this y speed and this speed here, this one, this x speed and y speed, if we didn't have it, it will be just okay, that's by one. But now we have this. If I want it to be 1, I'll put 1 in this variable y speed. If I want it to be 10, I have the ability to change that speed to, instead of always be 1, it can be anything I want. So that's the idea. Yes? No, this is because of the way things are implemented. Yes. Yes. So it's not about NetBeans. This is about, I mean, I've used that in 2 different programming languages, and they use the same kind of reference. So it seems like this is not just Java. So maybe there's some others. I think not. I think used more than just 2 with that inverted y-axis. So it seems to be something maybe that's shared among many programming languages. And the reason, honestly, I don't know why is it like that, but it doesn't bother me. It's just they said do it this way, and then I'm okay. If I want to find it, I will Google it. Yes.
You said, can I use an interface? Can I implement for more than one?
You can implement more than one interface. Yes. If you'd like to implement more than one interface, you put movable, and then you put another one, and then clonable, and then you implement another one. There's some. You see, these are examples of available. As you can see, interfaces. Most of them, they have this able thing: readable, runnable, but not all of them. See this char sequence. This is an interface as well, but auto closable, appendable. They try to make it always be like that. So it's kind of. So if you implement more than one, you can do that in comma with just putting commas. Yes, I did not mention that. Yes. So now what we'd like to do with the move up, we said if I'm moving a point up, what does this mean? Does the x change? No. So the x does not change. What is going to be changing is the y. What am I doing with the y? Am I incrementing or decrementing? So I'm decrementing the y, which means now this y is going to be by the speed that was mentioned. So I'm going to y minus. I said decrement. I thought you said decrement because now I would like to move up, right? So from here to here, if this was 10, this will going to be smaller than 10. So I'm going to decrease, right? This is 0, and this is my inverted, because it's an inverted axis. That's why you have to adapt to that. Yeah. So now if I move down, instead of the minus, it's the plus. Because if I'm moving down, now this is going to be, for example, here, so the y is going to increase, so I need to add. And the same thing, almost, if I move right. Now, if I move right, which means what happens to the x? Is it increasing or decreasing? I'm increasing, so if I move right, I'm going to increase the x by the x speed.
So it does not change with x, but it changes with y. On the same.
Now, if I'm moving right, do I change the y?
No, I mean with original coordinate, it does not change with x, just with y.
Well, you mean in here?
Yeah.
Well, the same thing happen here and here. If I'm moving up, just the y that is changing. For if I'm moving up or down, just the y is changing, but the x is not. If I'm moving right left, the x is changing, but the y is not. So the same thing, like the x is changing, but the y is not. So it doesn't matter if it's inverted or not.
I mean, it's positive when we go right on the
Okay, for both of these, yes, because of, you see, the direction of the x is the x-axis is on the same in both representations, so it will always be the same. But for this one, it will be inverted. Yes. Yes, a question.
Is the number on the toolbar?
The number what?
The number from the toolbar.
The numbers in the toolbar. I'm not.
Changing right.
These ones?
Yeah.
Yes.
Is it same?
Exactly. If this was my screen, this is going to be, as you can see, 0, 0. If I can reach it. Anyway, I'm just very close to it. And then if you just keep moving, these are the coordinates of my position. So now if I have a point here, now this is going to be, as you can see, it's actually the same thing. See the 0, 0, and then this is the y-axis and the x-axis. So this is the x, you see it's increasing, and the y, okay, I'll try to make it clearly increasing. You see the y. Anyways, you got the point. This is the y, and this is the x. Yes, I did not pay attention to this. This is a good check. Now, let's just go back to these. So the most important part is that this is the 0. It's in the top left corner, and then the positive y is here, and then the positive x is on the right. And now, if I move right, I need to increment the x. If I move left, I need to decrement the x. So just copy and make it minus. And I have my class. That is my movable point. So I have a point, and then it's going to be movable because it's going to change based on if I move it right or left. And I would like to show you something before going further, is to have a look at this code over here. Because I'm just going to use a movable point. Walaikum salam. If I do something like this, this is something we haven't seen. I did not spoke about it yesterday. But check this one. Movable is what? An interface. It only has abstract methods. How can I create an object from a movable? Actually, pay attention that what I'm doing. I'm doing upcasting. Actually, this implementing an interface is some kind of inheritance. Anyway, some kind of, because it's not exactly inheritance. It's some kind of inheritance but it behaves as if this movable was an abstract class. If movable was an abstract class, I cannot create an instance of an abstract class, which means I cannot do something like this. Because this is an interface and it's abstract actually. So the interface and an abstract class has something similar, is that they're almost basically doing this. It's like the interface is some kind of extreme case of an abstract class. An abstract class can have abstract methods, but it may not have abstract methods. Now, interface has only abstract methods, and that's some kind of thing that will allow me to do this kind of upcasting. So now a movable, this M1, it can be a movable point, a rectangle, a circle, so whatever, because everything is going to be implementing that interface, which means I can do this kind of upcasting. And that's one of the convenience as well by using interfaces. So now this one, if I use this thing, I'm putting a movable point, and if I display M1, now I know that inside movable is no toString, but inside this movable point I just defined a toString. You see, let me just show the navigator. I always like to have it. See this toString here? So I have a toString, which means as soon as I do something like this and I create that, I'm going to see this is the movable point x and 6, and the speed of moving x is 10 and the speed of moving y is 5, which means now if I'd like to move m1 dot move up or move right or whatever, where do you want to go? Let's move right. Now if I move right, what should I see next? Because I'm moving right, I'm going to increase the x by 10. So this is going to become 15.6. I just moved it 15.6. If I move right twice, then it's going to be 25 because I moved twice. Yes. If you have an interface, that interface is like some kind of an abstract class, and all the classes that are implementing the interface can be upcasted into that type. That's why I can do this. Actually, what I'm doing here, this is upcasting, because movable is some kind of a super class of the movable point. It's not exactly a superclass, but it's like a superclass because movable point is implementing a movable, so I can have this kind of relationship. It's not like the same as I'm inheriting, but it's kind of. That's why we say with the interfaces, Java is simulating multiple inheritance, because it can inherit from different things. I mean, different class. I mean, from one class, but also from interfaces. And because of that, it may be in two types, something like that. So now, this was just a small parenthesis because I did not talk about it yesterday. Now let's talk about the other, this movable circle. Now I'm going to add this class plus the other one, this movable rectangle, which is basically the same thing, and just the way it works is going to be different. Now let's add a new class, movable circle. So in the movable circle, what we have is the radius, that is an int, and the movable point, that is a center. And this, let's do that. Movable point is center, and this is going to be private, and the private int radius. It was int, right? Yes. Now this is a class data type, which means now this is going to be by default is going to be null until I initialize it, and I'm going to use the constructor to initialize it. And I'm going to initialize both of these? Well, not really, because you see in this constructor I need to specify the x to y, the x speed and y speed, then the radius. So I'm just going to select this and generate. And later on I need to type myself the x and y and x speed and y speed. So let's just do that. Or copy it, that's better. Copy it from here, it's even better. Yeah, let's do that. Okay, and a comma. Now I have this x, y, x speed, y speed in the same order that they were mentioned. And that's important to respect the order because it was specified in that order. You have to respect that. Now, once I have these things, these first four are going to go to initialize the center. So the center is equal to new movable point, and with all these things. So these four are going to be used to initialize the point, the center, and the radius goes to the radius. Now that I have this, I need to have the toString, and let's just generate that and see, check this thing. Now this toString is using the center as if it's some kind of a value, and this is only possible because this center, what is data type? It's a movable point, and a movable point has a toString, which means what I'm going to see if I do something like display this circle, I'm going to see this, the movable circle has a center equal to a movable point of this x, y, x speed, y speed, and then there's the radius. So it's going to be like things nested. Sorry?
Like we'll bring that toString into this.
Exactly. This is going to be a toString inside another toString, yes. And I still did not, I did not put the relationship between this movable circle and the movable. Now, if I'd like to do that, I just need to mention that this implements movable. Now, as soon as I do that, I have to let's do some more copying and pasting. I'm just going to copy and paste these and then adapt whatever needs to be adapted. Now, what I would like to do is, okay, just remove these, just so they will not. Okay, just remove everything. I just would like to start from scratch. Now, if I'd like to move up, what actually needs to be moved up in a circle? Just the center. If you move the center, then the whole circle is going to move because the radius doesn't change. You just move the center. Now, if I'd like to move the center up, which basically I shouldn't have maybe deleted this, I could just, it's the same code that I move a point. Basically, I'm just moving a point now. And if I'd like to move the point, but I don't have this y. Because this y is declared where? In the movable point. But I'm here, I don't have a y, but what has the y is the center. The center has the x and has the y. So this is going to be center dot. And then the speed comes from also the center, the point, because this is y speed and y, they are coming all from this variable movable point. Because what I'd like to do basically is, let me maybe take it a different direction. Now, if I'd like to move, let's say if I'd like to move up my circle, I just need to move the center of the circle. So if I'd like to move the center of the circle, I just need to specify center.y. If I would like to move it up, which means I need to subtract with the speed of the y. So everything is about the center. Now, if I'd like to move down, it's the same thing, but except of minus, it's a plus. You remember y is a plus and minus. If I'm moving down, I'm adding. If I'm moving down, that means the y is increasing, so I need to add things. If I'm moving up, the y is decreasing, so I need to subtract things. So that's why. Basically, this is exactly the same thing that we had here, except that instead of just using this of move right, instead of only do this, what I need to do is center dot x is going to be increased by center dot x speed, and same thing with this thing. With the minus, if I move left, I just to decrease the center. Now my movable is not the point. Is now it can become the circle. So if I make it circle, this is my movable circle. But circle takes 5 it takes the speed. Let's say I'm going to put 10 10. Let me put these as to be, for example, 5 5. So this is the x and y, the x speed and y speed, and the radius is 25, let's say. So if I just display this thing, what I'm going to see, this is a movable circle. Its center is a movable point that is at this position. That's the center. And then the radius is 25. And if, for example, I move right, what is going to happen is that I'm going to add 10 to the x, which will make it 15, and then 5, and the rest is not changed. Is that okay? Now let's move forward and keep going. We're going to be doing the same thing this time with the rectangle. So movable rectangle. Yes.
Can you go back to the website?
Website.
Yes, here. What does this symbol mean? Implements
Which one?
this symbol.
Which symbol?
This one.
What this one? Have to say it. I'm not seeing your screen. I'm not seeing even your finger. Which one?
The diamond one.
This one?
Yes. That's for implements.
No. That's for this class is using this class. How is it using it? This class is using a movable point. That's what it means.
That's the symbol.
If you go back here, that's the same meaning again.
Yes, yes.
This class is using movable points. So now the movable rectangle has top left, bottom right. Why do we represent a rectangle with the top left and bottom right? We know that a rectangle is like this, so it has 4 points. So why just 2, top left, bottom right? Because with just these two, just give me 2 points, and I'm going to define a rectangle in those 2 points. Because give me these 2 points, this is going to be a rectangle from these 2 points. So to define a rectangle, I don't need 4. 2 are enough. Just give me these 2. I'm able to find the others. Because a rectangle is just straight lines, and the angle is sorry, the angle is 90 degrees. That's why just give me 2 points, I'm able to reconstruct that rectangle. So this is what we are doing. We're going to be also implementing this movable, except that this movable now is going to be slightly different from the way we move a rectangle is different from the way we move just a circle. Now a circle we were moving only 1 point. Now we need to move 2, and let's see how this is going to unfold. So let's just implement all these, and then I'm going to make them just empty like we did before, and I'll deal with them later. Okay. Now let's just have the top left and bottom right. These are all ints. No, movable points. So I have movable point, top left, bottom right, and they're all private. So private movable point, top left, and then same thing, bottom right. And I need a constructor to initialize all these, and the constructor is going to be kind of interesting because I have x1, y1, x2, y2, and x speed and y speed. What does this mean? I have 2 points, which means I have 2 coordinates, 2 x's, 2 y's. But the speed is only once. The speed has to be the same. If I'm moving these 2 points, they have to move at the same speed. If they don't move at the same speed, I'm changing the size of the rectangle. Now if this one, for example, if I'm moving these 2, this one moves by 5 and this one moves by 10, Now the rectangle is going to be, instead of just moving up, is going to become, this is going to move a little bit by 5, let's say. So it's going to be, for example, here, and this is by 10, which will make it here. So now it's a different rectangle as this was. So it's become a different size. We don't want that. So that's why we would like to, if we move a rectangle, we're going to move everything to the same speed. So everybody is going to move by 5, which means 5. Okay, everybody's here. So this one also is going to be moved by 5. So my rectangle is going to be moved up by 5. So it's the same rectangle, but it's moved up without changing its size. That's why we have only this one speed of x and one speed of y. So I'm going to have this int x1, int x2. The way it was is y1, and then int x2 and int y2, and then int the x speed and int y speed. Now once I have these, I need to instantiate this top left equal new movable point, and I need to choose, let's maybe put this 1 and y1, and then the speed is the same, and the bottom left, the bottom right is going to be x2 and y2, and the speed is the same. Now let's just have this toString, and then let's make it move. Yes.
X1 and Y1, clear and movable. It's only X, not X1 and Y1.
These are just parameters, which means these are variables that are going to be used to put some values in them. Now, what this means is that this movable rectangle, if you'd like to instantiate a new object from a movable rectangle, you need to give me 5 or 6 values, 6 ints. The first int is going to be sent to the first, so it will be inside movable point inside the x. Yes. So it's just, this is just the name of a variable that is going to be temporary, because I'm just put this here to take it and put it in the right, and the definite place is this one. So I'm putting it inside of the x of the movable point. Yes.
Go to rectangle. Can we just do for top left is x2, y2, and
Yes, you can do that if you want, because nothing was mentioned which one is which. You can choose which one. When you initialize, this is going to be the top left, or no, I would like this first one to be the top right, the bottom right. So it's up to you. Yes, because nothing was mentioned, but so. Now, to move up a rectangle, what we need to do, we need to move the top left and the bottom right to the same speed. So the top left dot what if I do something different? What if I do this? What's inside of this move up? It's just going to change the speed to, adjust it to the speed of the y. So this, actually, I can use the bottom right dot move up. Now, if I'd like to move up the rectangle, I just need to move up the 2 points. Instead of, I can do also the same thing and then put the code myself and say top. I can put this top left dot. If I'm moving up, which means the x does not change, the y is changing. The y is actually reducing. So I'm going to put y minus equal by the same speed of the y speed. So this is basically what I'm going to do. But if you look inside this move up, what is happening inside this move up of the movable? I'm just taking the y and then subtracting from it the y speed. So basically it's the same thing, except that I don't need to take care of the details. I just call the method because it's available. This top left is a movable point. This top left is a movable point, and this movable point has a way how to move up and down and right and left. I can just use that. And this is going to make my life easier, because now move up means just move the top and the right and the top left and bottom right. And I'm going to, you guessed it, I'm going to copy and paste. Move down, you just move this down. Move right, same thing, move this right. Yes?
Can we do it in the circle?
Yeah. You can do that in a circle, but yes, we can do the same thing in a circle. But in a circle we have just the center to move up and down. Yes. Let me just copy and paste before I forget, and then let me change these. Now just make sure that I'm not doing some kind of wrong. So in the move down, everybody's moving down, moving up, moving up. Now what I can do, and I don't want to confuse you, is to zoom in, zoom out, which is, I mean, grow or shrink the rectangle. How can I grow or shrink a rectangle? One's moving up, the other one's moving down. Now I'm growing the rectangle. If I'm shrinking the rectangle, one is moving down, the top left is moving down, and the bottom right is going up. So I'm just going to squeeze it. And
So we should do two methods?
no, I'm just saying that if I want to have this kind of shrink and increase, I mean grow and shrink, I need to add some new methods to that, but I don't want to do that. Now that your suggestion was to, instead of doing this, I could have done center dot move right, for example, in this case. So I'm just going to put it as a comment, just to leave the trace that it's possible as well. Now if I go back to the main, and instead of this movable rectangle I have this movable circle, I have movable rectangle. Now I need to put two different set of coordinates. Let's put 3 and 3, and then yes, I don't need the radius anymore. And this is weird. No, it's not. Okay, now I have this kind of a rectangle, and check now, if I have a rectangle, it's going to be two movable points. The top left is a movable point, and this is its speed and position, and the bottom right is another movable point, and this is its coordinates and speed. And if I move right, what should happen is that everybody should move right. The 2 points should move right. So if I do that, means now instead of having this 5, 5, it was 15, 5, and this one instead of 3, 3, it's 13, 3. So definitively it has moved, it has preserved the same size. Up, down, same thing. Okay? What we can do as well is the movable square, because it's fun. The movable square is not part of the exercise, but do you want us to do it? Or it's less confusion? It's too confusing for now? Let's be courageous.
How we can
Let's have a movable square. The movable square is the same. Actually, I'm not going to be doing anything else but extends the movable rectangle. Is it? The only difference between a square and a rectangle is just I need to make sure that they have the same size. So then, how can I need 2 points too, or do I need just 1 point? I need 2 points for the square. Actually, 1 point plus the side, that will do. But 1 point in is not enough. 2, well, if I chose to use 2, I need to make sure that the two are at the the height and width is the same, so it's going to be more confusing. But what I'm going to do by doing this, by extending the movable rectangle, I have a problem. What is the problem? I don't know what. Constructor movable rectangle in class movable rectangle cannot be applied to given types. Int found none. And this is the problem with the constructor, not with the implements, because this is implementing already the abstract methods from the movable. So the problem is not about implementing the abstract ones. The problem is that I don't have a default constructor here, and the only constructor it can use is this one. Now if I'd like to use the kind of logics, the 1 point on the side, well, how can I do that? It's kind of more I need to change the constructor. I need to use another constructor to use that. Now this constructor of the rectangle uses 2 points, so I need to find a way how to make these 2 points to be close, and this is a lot of complications. So what do you, I didn't get that. So I have, let's say I have this I have these 2 points. Now if you give me 2 points, I just need to make sure that this is equal to this.
I mean the top side and the bottom side, this side, and take the center. If you're equal to the center of the base, same side.
That's a good thing. It gave me an idea actually. I can just give me one point and give me what's this side. Yes. And then how to implement that is that we are going to be calling the constructor of the superclass, but we need to calculate the position of this second point. So you give me 1 point. Let me show you what I mean. I hope I'm not going to confuse you more.
I think we can leave, for example, x. We just use y, or we just.
No, we need x and y. It's because a point needs x and y. So, for example, let me show you what I meant. I'm going to have a constructor that is movable square. This public that is going to take one movable point, or maybe just into the same logic, int x and int y. This is the point of the top left, let's say, and then the size of the side. Now let me show you what I mean. If you use, for example, you give me the point is this one and the size is 4. Okay, now imagine that this is my axis. This is 5 by 5, just to make it easy. Okay, even though it's not, doesn't look like this, and the side is 4. Now can I know what's the position of the second point, the bottom left? Yes, that is, for example, the x. This is the x. The x would be what? 5 plus the side. So it should be 9. It's 5 plus 4. So this is going to be the place for the x. What about the y? Another 4 here. So it's going to be 9, which means what I'm going to do, I'm going to take the x plus the side. That's going to be the x of the bottom left, and the y plus the side, the y from the bottom left. And then I can do something like super x and y, because this is the top left, we don't touch, and then x plus side and y plus side. Of course we missed the speed thing. I can just need to have the x speed, y speed, y speed, and now just this is the first point, bottom, top left, bottom right, and the x speed and the y speed. Now all I need to do is this, and maybe just have a toString. Not even toString. I'm just going to, no, I can use the toString. Let me have a toString that is going to be this is a movable square and then I just would like to display the side. How can I display the side?
Robot square. Put the
I have a problem.
what? The height?
Yeah, how can I get the information? I cannot display that. Let me just.
Put getter.
I can put a getter. I don't want. Yeah, that would be the easiest way. Is to put getters and setters here to be able to get this top left and bottom right, because I don't have them. Also the speed, I don't have it. How can I get this speed? Well, I can get it from top left and bottom right. If I have these two, I can have the others. So maybe I can have these getters and setters, or maybe change this to protected. That's another way how to be able to deal with it. Let's make the easiest one. Protected is kind of the easiest option. If I make this now protected, means now I'm able to say that this is the top left and top left. This is the variable and going to be movable plus bottom right maybe the speed as well. Well, anyways, now this will allow me to define a movable square that can be from just you give it 5 5 and then the speed and the side. Which one is which? Let's give the side of 4. Now just to show that, now this is 5 5, the side is 4. Why do I know the side? Because no, this is the speed, the side is the last one, so I need to go back. The last one should be the 4. That's bad pasting. Now what happens is that if I display this, I should see this is a square of top left 5 5, bottom right 9 9. Remember we did the calculation. If this was 5 5 and the side is 4, which means now this is 4 plus 5, that's 9. This is 9, and this is also 5 plus 4, that's 9, which means here this point here is 9 9. And if I just display this, top left is 5 5, bottom right is 9 9. Anyways, this is just me having fun, and I don't know if you're following me with this fun. That doesn't look on your faces that you're having fun. Anyways, forget about this square. If it's confusing, let's get these movable rectangles and circles and points and make sure that you understand them. Do you have any questions regarding these? Okay, so let's stop here and then let's talk about how we can use